Hi, my name is ROSNIZA binti ROSMADI. So in this video, I will explain about past year chapter 7 for question 13. So let's get started. So for question 13, A. In a series of acid of the halogen group, hydroiodic acid Hi is the strongest acid, while hydrofluoric acid HF is the weakest. So for the question 1, explain what is meant by strong and weak acid. So the keyword here is explain. So we need to explain the definition of the strong and weak acid. So the answer is strong acid dissociate completely in an aqueous solution to produce high concentration of H3O+. Then weak acid dissociate slightly in an aqueous solution to produce low concentration of H3O+. So we will get 2 marks here. One when we explain the definition for strong acid, and another one when we explain the definition of the weak acid. So for the second questions, briefly explain the main factor determining the strength of the acid. So for the keyword here is explain, main factor and the strength of the acids. So we need to mention the main factor, then we need to explain it. So the answer is, the main factor determining the strength of the acid is bond strength. The stronger the bonds, the hydrogen atom is held more lightly and thus less likely to release. So we will get 1 marks when we mention the main factor, then 1 mark when we explain it. So the total will be 2 marks. So next, question 3. Calculate the degree of dissociation of 0.2 m HF solutions. So the keyword here is calculates degree of dissociation and 0.2 m HF solutions. So they already given us for the molarity of HF solutions and the value of concentration acids. So firstly, we need to do the ice tables. We ignore the H2O since it's a liquid, so we focusing on the aqueous. So we substitute the value of given, which are 0.02 to the ice table. Then we use the formula of concentration acid, which are reactant over products. We ignore the H2O since it's a liquid. Then we substitute the values that are given and the values that are from the ice tables. So we will get 2 answers, positive and negative, but we ignore the negative because it's not accepted as there's no values in negative. Then we will get X equal to this. So we will know that X is equal to the H3O+. So then we answer the questions. The question was the degree of dissociation. So we use the formula concentration H3O+ ion dissociate over initial concentration of HF. So this is what we get when for the X over to the 0.2 that given, and the answer is 0.0565. So for the marks, we will get 1 marks from the ice tables and 1 marks when we use the formula concentration acids, and 1 marks when we get the values of X. Then the last mark we get from the when we answer the questions. So next, B. Acetic acid is a weak acid with concentration acid. Okay, it's give the question give the concentration acids. It dissociate in water according to the following equations. So they give us the equations. So for the first questions, rewrite the above equation and label the conjugate acid and conjugate base. So for the keyword here is label for the conjugate acid and conjugate base. So firstly, we rewrite the equation given, then we need to determine which are acid and base. So from here we know that CH3COOH is acid and H2O is a base. So as for acid, the conjugate base is a H3C, CH3COOH, because we know that it don't know the protons, so it will build the conjugate base. Then for the H2O, it's a base. It's paired with the H3O plus. We know that it's a conjugate acid because it accepts the protons. So we get 2 marks here because we label the conjugate acid and conjugate base. So for the question 2, determine the pH of the 0.10 m acetic acid. So firstly, we need to use the ice tables. So we ignore the H2O like usual because it's a liquid. Then we put the 0.10 m's to the tables. Then we use the formula of concentration acids. Concentration acid already given in the questions, which are this. So we substitute the values given to the formula. Okay, since K is very small, assume 0.10 minus X to only 0.10. Okay, only apply this method if K concentration of acid or concentration of base givens are less than this. We only use this method if it only less than this. So since it's this, so we need to use this method. So we substitute, we will get X equal to this. So when we know that X is equal to the concentration of H3O plus. So the question wants to determine the pH. So we use the formula of pH equal to negative log H3O plus, concentration H3O plus. So we substitute the values that we get from X, then we will get 2.87. So for the marks, we will get 1 from the ice tables, 1 when we use the formula of concentration acids, and another one when we get the values of X, and then the second last we get from when we use the formula of pH, and lastly when we get the value of pH. Okay, so next question 3. Predict the persistence of dissociation when the acid concentration is increased. So the keyword here is predict the percentage of dissociation and the acid concentration and increase. We know here that we need to compare the percentage of dissociation and acid concentrations. So the answer is percentage of dissociation decrease with concentration increase. Okay, how we know that? Okay, from the formula given, we know that percentage of dissociation are not directly proportional to the concentrations of acid. So when percentage of dissociation decrease, so concentration increase. Okay, that's it from me. Thank you for watching. I hope you guys will understand what I explained. Thank you.
That's all for this video. Please do remember, subscribe, like and share. If you have any question, please don't hesitate to consult with your lecturers. Stay at home, stay safe. Bye.